I'm Steve Macko. I'm a professor in environmental sciences at the University of Virginia. I study all kinds of ways to understand the geochemistry of the Earth using mass spectrometry and advanced chemistry. My purpose here at the GIFT is to act as kind of a rapporteur and give extended ideas about the summary of everybody that's been talking at the GIFT, from changes in ice to the changes in temperature and the pH of the oceans. I start with this because it's a wonderful painting. If you may know, but the method called batik, there's a woman, Mary Edna Fraser, who does air photographs, and she takes them into the future. And so here is what Charleston Harbor in South Carolina, United States, will look like in 100 years when it's flooded because of higher sea levels. And so I thought this is so appropriate to start a discussion about, you know, what are the summaries from all of the talks about looking into the future with one of her slides. So what we've been seeing is really a perspective of the Earth and how it's going to change. And we've been focusing somewhat on the ocean, and I think it's good because the ocean is 71% of the Earth's surface, and on the other side, we live on the land, and the land is going to have many changes with, as you know, the timing of the seasons and the productivity and aridity, and you've heard a little bit about that, but not enough. And I guess when the first speaker arrives, about 11 or so, you'll get to hear that too. We've been talking a lot about the warming of the Earth and of the oceans and sea level rise, and Larry just gave you this wonderful presentation about the loss of ice cover. You've heard about ocean acidification, and so I'm going to come back to these. But some things about the changing Earth that we have totally missed, I think, and I'll mention, or maybe we can even think about this for a future gift, about the global pollutants, because we've got things that were alluded to a little bit about oil pollution, plastics. You know, this is a major change for the Earth and the amount of plastics that go put into the ocean. And this really wasn't mentioned, but how much excess nitrogen. You know, humans produce more nitrogen now, fix more nitrogen than nature does. And so we are changing the Earth by the amount of nitrogen that's available. The productivity of the Earth, the diversity of the ecosystems, and we haven't even talked, I'm going to talk with you a little bit about fisheries and also about some migratory birds. So these are changes in the Earth. So prepare yourself for more depression. You know, some of the changes that have been that we've been not talking about or have really a direct application. You can point to human activity and say, humans are causing this change. And one of the really easy ones is you can see the plastic waste. There's so much plastic waste in the ocean, and that there are islands. And I say the state of Texas, and I don't know how big Texas is relative to Europe, but Texans would say it's bigger. Okay, and that's just Texans. Okay, but it's the unknown effects. You know, how it's changing the whole Earth. And it's entering food chains, endocrine disruptors. You know, this compound called BPA is there. Oil spills are changing the Earth because of the amount of, and Larry alluded to this, that, you know, the Gulf of Mexico is now changed forever on our scale because of the oil that's in there. We're losing diversity, we're changing the food webs and the environmental habitat. We're overfishing and there's lack of stock management. This is changing the Earth. You know, when we're trying to feed 7 billion people, we're changing the Earth by these. And so that's things that we haven't really talked about in this. And those are important aspects of this changing Earth. If you look at how many million tons of plastic enters the oceans every year, and it gets into the food chain. These are the obvious effects. But there, you know, you can go out into the ocean. There are 50,000 pieces of plastic per square mile. And it's just this amazing change to this pristine ocean. So, but I'm not going to talk about that. Maybe a future gift. We can talk about oil, and this is the Deepwater Horizon spill that Larry was talking on. This is changing the Earth. We're spraying compounds to correct the oil spill. It's very interesting. The word for this compound is COREXIT. And if you say it really fast, it says corrects it because it corrects it. It corrects the oil spill. And there are literally, millions of gallons of this that were sprayed in order to get rid of the blemish of the oil on the surface. But as we continue, we are addicted to fossil fuels. And as we continue to use the technology to go into deeper and deeper waters, this is going to continue to happen. There will be another oil spill. And it will be as massive as the Deepwater Horizon. And so Macco said that when we were at GIFT in 2014. You can quote me. But I'm not going to talk about that very much. We can talk about the changing Earth, that throughout the planet are these areas that are called dead zones. They have too much nitrogen. They have so much productivity. When the productivity dies, it makes the zones anoxic. Fish can't live in them. We have one in the state of New Jersey in the United States. Has been suggested that the state of New Jersey is about the size of this dead zone. And New Jersey doesn't like that very much. But these are areas that are caused because we have so much nitrogen entering into the Gulf of Mexico. These are changes for the ocean itself. That, this is making the whole food chain different. I'm not going to talk about that. But the Earth is changing, and we've been talking mostly about climate change, and I'll emphasize in my rapporteur position to talk about these climate change. And we've talked about the usual suspects, that carbon dioxide is the big player out after water. But methane, we've talked only a little bit about, and methane, I'm going to come back to this, because methane has 20 times the effect of carbon dioxide. And the methane release is huge that's going on. Most of the emissions come from the developed world in a few countries. These could be changing. I'm going to talk with you about some of the changes as the Earth warms and how those can be changing. So some of the changes that we can see in the Earth have a direct relationship. The human activity causes this. And we can identify the effects, and some are even less. And Larry had said this really well, that we really don't know. And Dr. Orr said it. He said, well, how much can we actually predict of some of these things? Warming of the ocean, okay, thermal expansion is the player right now. And as we get more ice melt, there's going to be more sea level rise due to that. But right now, the warming of the ocean is going and causing the sea level to rise. There is melting of glaciers and sea ice going on. Coastal environments are being lost. How important are these coastal environments? And then, to my mind, and I think Larry was one of the huge topics is loss of sea ice, but the other one is this pH, because this is predictable. This is first principle of chemistry. Chemists love this kind of thing. As bad as it is, it's very predictable. All of you that did the experiment of blowing through the straw and changing the pH of your solutions, that is what's happening to the ocean. Other effects, and this is what I'd like to also talk about, are these what I would call cascading impacts. When you have warming, there's going to be releasing of more methane from gas hydrates on the seabed. And I'll come back and show you a slide on this. Or permafrost, and the greenhouse gas amplification. Methane has 20-something times the effect of carbon dioxide. And when we talk about a changing Earth, the loss of diversity somewhat from global warming, somewhat from the pH change of the ocean, somewhat from just poor fisheries management. The skills of humans are terrible. And I'm going to come back to that because that's important. So you've seen this too many times. The Earth is warming. And you've seen this on another form that said that it's the loss of ice cover has been going on for about 20,000 years, and this rate has been very high, and now we're still in this rate of increase of temperature and sea level rise, and so it's been pretty measurable. And a lot of this has been attributed now to human impact rather than to the natural events of the past 20,000 years. So, in addition, if you go to the Arctic and the Antarctic are two areas of the planet that are going to be the most sensitive. We know that the Arctic is going to warm more than most of the rest of the planet. We know that the pH of the water in the Arctic is going to drop more because it doesn't have the buffering capacity of the salts in the ocean. And this will cause huge change. And that change is going to happen to the food webs and to the all the organisms that we think of for the Arctic, and the implication as it will happen will be to the atmosphere, the ocean dynamics. So regions that are vulnerable, and this is classic. So you think about the regions that are vulnerable. So here's how much sea level might rise. And we can pick out areas of the Earth, you know, places like Bangladesh are going to be inundated. Places like southern Florida, and New Orleans is already below sea level. And parts of China, amazing here, are going to be underwater. And here's England and obviously Holland are underwater already. So these will be affected. There are going to be millions of people, hundreds of millions of people are going to be affected by sea level rise. This is predictable. And so some of the changes of the warming, of sea level rise, and some of the effects are going to be obvious. And this is, as we go and have more of an ice-free Arctic, we're going to be able to explore for minerals and for oil in the ice-free Arctic. As we go and we have an ice-free Arctic, there's going to be more transport between the Atlantic and Pacific across the passages there, because they're not going to have ice there, with the assistance probably still of icebreakers. There's going to be increased tourism. You know, some people say, well, these are all good things that might be happening. But even as we have this ice-free Arctic, we don't know very much about the fisheries and the ecosystems, how they're going to be modified by these great changes. And in fact, this is now one of the things that to consider as we explore for oil in the high Arctic, and we have shipping traffic go across the high Arctic, we are totally unprepared for an oil spill. And I mean, it's total, you know, and Larry in the discussion said it, that we have no way to contain or clean up an oil spill in the Arctic. And not surprising to you, in 2006 in Prudhoe Bay, 1 million liters of oil was spilled by BP, no less, and there was there's a total lack of ability to contain that oil. And so we are totally unprepared for such an event. Gas hydrates. Gas hydrates are crystalline water gas associations. They exist in permafrost, they exist in the seabed, and as there's warming, there's stability. This is physical chemistry. Stability will be lost and they will decompose to give gas to the atmosphere. The Arctic alone may have 400 gigatons of gas hydrates. Okay. And so these are students just holding it and it burns. These gas hydrates are being released in areas that are very rich, and as it warms, they're decomposing. There are meters of coastline that are being lost, perhaps even on a daily basis on the North Slope of Alaska. You know, where gas hydrates exist, there will be loss of gas, there will be an increase. Remember, this is 23 times the warming of CO2 in methane. And there could be thousands of gigatons of gases released, methane, to the atmosphere. Canada will become one of the great producers, and Russia will become one of the great emitters of methane to the atmosphere because it's natural. You know, they can't do anything to stop it. And they'll be increasing the enhanced greenhouse gas effect. We can see it already. This is, you know, off of Svalbard Island, the Siberia, we can see methane concentrations rising in the ocean right now. You can see methane bubbles. These methane bubbles don't come to the surface, they're filling the ocean, and we don't know how is this going to affect the respiration on the fisheries that are there. Some of these locations are really rich in fish. The methane is going to be accelerating warming. It's an enhanced greenhouse gas effect. And Larry told you about him spending the 11 years. I said many, many hours, and that's the equivalent. I've spent many hours below the surface of the ocean, and when I was on a dive in a submersible, we actually discovered the first time a gas hydrate above the surface, this mushroom-sized chunk. And literally, it's on the field of stability, and when we went there about a week later, it was gone, because it was too warm for it to be stable. But this is what the gas looks like. It's explosive when it goes. Regions that are vulnerable to sea level, if we come back to it. So I was talking about some of the obvious regions, but look along the Arctic too, where there could be regions that are vulnerable. Well, why do I mention that? Because there are migratory birds, and one good example of that is the red knot. The red knot travels the greatest distance on the planet from tip of South America all the way up to the high Arctic. Those locations where it nests over in the summer are just going to disappear. The locations that it stops over here and feeds on the eggs of these horseshoe crabs, where it literally doubles in size, the timing of those migrations are going to be changing. The red knot is incredibly threatened right now. The populations are so declined that people are concerned that they should be endangered. In fact, it's just one of hundreds of species that make those migrations, that as global warming happens, as we have loss of coastal environments, that these birds are going to be, using the grounds for breeding, and they will be, or already are, in decline. Millions of shorebirds are going to vanish as a result of global warming. Another cascade of the events. Larry showed you this, and this is really impressive about, here's the high levels of 79, and here's 2012, which is kind of serendipitous for a lot of reasons, that 2012, because there were a lot of things going on, but that was sea level. And he showed you this great picture to really drive home the point that there was ice and then there wasn't ice. Well, I went into the website. This is the National Snow and Ice Data Set. This is yesterday, okay? So you can go there with your class and watch. And so if you look at yesterday, this is 2014. It's below 2012. So there's the 2012 ice cover, and here's 2014. So it's less. Think about 2012 was the lowest ever seen. It's not going to say that there are these kinks and valleys that are going to go on and might cross back over like 2013, but at this moment there's less ice in the high Arctic over winter than there was last year and in 2012. Why do I mention this? Something that we were just beginning to hear, and one of the things is that there's something called the law of the sea, okay? And then the territorial limits of all the countries that signed and did not sign onto the law of the sea is roughly this edge of this continental shelf, or 200 miles. And this is, so here's, what we have are all the different countries, and here's Alaska and Canada's territorial limits. There's an area across the high Arctic that has resources, minerals, fisheries, that we don't know really how much is there. We don't know how many fish are in the high Arctic, and nobody really has territorial claim to this huge area. Well, what protects it, has protected it for all this time from oil spills or from overfishing? The ice has done a great job, but the ice is being lost. If you look at the ice cover, so this is, this is international waters, and if you look at that, all of this area, here's off of the United States, off of Canada, and off of Russia. This is ice-free. This is still under ice, but this area is ice-free for anybody to come in and explore and fish to their heart's delight. Here's the United States territorial limits. So that's ice-free. That's international waters. You could take a boat through the strait and go in there and fish as much as you wanted to. What's going to happen as we have warming of the ocean? We're going to see species of fish that are here today. They're going to start moving into those areas much greater. See, you see there's not much here, and all of a sudden it becomes very high in fish. Something is going to be more attractive. You're going to say, I can get a lot of fish pretty cheap if I go into international waters and go after the Arctic cod. They're not there today. They will be there tomorrow. So we don't know what this is going to be doing for the effects on the fisheries, the warming. We know that the timing of spawning is dependent on temperature. Almost all fish have some temperatures of spawning. There are the energy transfer. As you go up trophic levels, these small fish are eaten by big fish. And we don't know what's going to happen when those small fish aren't there to that trophic structure. The habitats for spawning. There are fish that depend on ice for laying their eggs. They lay their eggs in the ice. Well, what's going to happen to the fish when there's no ice? So the benthic productivity, I'm going to come back to this, because benthic productivity, these are organisms that live in the benthos, the crabs, and that depend on something called ice algae. Ice algae, I'll come back to, actually is algae that attaches itself to the ice. The primary production, some people have said that it's going to increase because it's going to be warmer, but the truth is, are there going to be nutrients in that ice-free water, or enough from the meltwaters to support a greater productivity? These are organisms, they're called coccolithophores, and there's a bloom of coccolithophores right there, and this is an incredible amount of productivity. This is off of Newfoundland, so it's not the Arctic. But ice algae, which is this like diatoms that grow attached to the ice, and here's a better picture of it. So here's the ice, and these are algae that are growing attached to the ice. You're looking up through it now. Might produce 25% of the total Arctic productivity. Now think about it. You don't have ice. You don't have ice algae. Or you have ice algae, but it melts months earlier than it's supposed to be. What's going to be feeding the organisms that are migrating in to get to that productivity a month later? The ecosystem will be changed. In fact, other organisms that depend on eating things that are in the water column, like the whales, seals, are going to be then impacted. A cascading effect of warming and the loss of ice on those populations. These organisms will be further stressed. And what about modification of the productivity in the water column itself, in the ocean itself? Well, you know these, you probably have seen all these trophic pyramids, and everything depends on phytoplankton. Well, if there's going to be less productivity, especially in the high Arctic, what's going to happen to the organisms that are higher up on the food chain? There will be an impact. Spawning times, the higher temperatures, we don't know what's going to happen to those populations. Organisms like the herring depend on a particular temperature for spawning. What's going to happen to them? Critical temperatures that exist for all fish are going to be changing. We don't know the cascade. So the stock sizes under the ice, we don't know the cascade. I know I was in a meeting for the Law of the Sea with a Canadian minister from fisheries, and she was basically saying we are anticipating greater fisheries in the Arctic. Well, we don't know how many fish are there in the first place. Are we going to take whatever fish we can get right now before we know how many are there? That's mismanagement. Ecosystems of the Arctic are terribly complicated, and as we change the productivity, these ecosystems, whether they are Arctic or in the Antarctic, are going to be impacted. So, you know, it's very complicated. The ice sheets themselves are showing an acceleration in melting. And for the first time in Greenland, the ice of Greenland was seen to be essentially melted on the total surface back in 2012. I said, you know, 2012 is serendipitous, and it's bad serendipity. But for the first time in 2012, this should convince you that, you know, warming is impacting not only the Arctic, but the ice sheets of Greenland, and that is impacting the Atlantic Ocean itself. To convince you further, I'm going to show you a clip.
I'm on the phone with Jim on one of our regular check-ins. Jim, nothing's happening.
Hey, Jim. It's going well. We had some serious bouts of wind, but other than that, things are fairly well.
This is from a movie called Chasing Ice.
It's starting, Adam, I think. Adam, it's starting.
Oh, wait, Jim, this is the big piece is starting to cast. Let me call you back.
All back. Okay, bye.
Still going?
Yeah, in that V section right there. Holy shit, look at that big bird rolling. All four are running, right?
Yeah. Look at that. You see how, look at the whole thing.
glacier ice breaking off into the ocean. That's not a whale, it's a piece of ice.
The calving face is 300, sometimes 400 feet tall. Pieces of ice were shooting up out of the ocean 600 feet and then falling. The only way that you can really try to put it into scale with human reference is if you imagine Manhattan. And all of a sudden, all of those buildings just start to rumble and quake and peel off and just fall over and roll around. This whole massive city just breaking apart in front of your eyes. We're just observers, these two little dots on the side of the mountain. And we watched and recorded the largest witness calving event ever caught on tape.
So how big was this calving event that we just looked at? We'll resort to some illustrations again to give you a sense of scale. It's as if the entire lower tip of Manhattan broke off, except that the thickness, the height of it, is equivalent to buildings that are 2.5 or 3 times higher than they are. That's a magical, miraculous, horrible, scary thing. I don't know that anybody's really seen the miracle and horror of that. It took 100 years for it to retreat 8 miles from 1900 to 2000. From 2000 to 2010, it retreated 9 miles. So in 10 years, it retreated more than it had in the previous 100.
This was sponsored in part by National Geographic. The guy's name is James Balog. And so there's a whole film called Chasing Ice. That clip is available from on YouTube. In fact, that's what I captured it in case I didn't have it here. All right. So what are the cascading impacts of this great amount of ice breaking off? And I mentioned this just last week. The Pine Island ice shelf in Antarctica had a piece break off that is 7 to 8 times the size of this event. So it's like 7 or 8 times the size of Manhattan. Broke off last week. It's an ice shelf. What's going to happen? Well, I bring to your attention that the number of icebergs is increasing. Why is that going to be important? Well, where are these ice pieces breaking off? It's a little bit like the Titanic, that they're crossing over into the greatest shipping traffic on the planet. The greatest shipping traffic and the number of icebergs are now going to be affecting that shipping traffic, a cascade of global warming. The currents, things like the currents are going to be affected similarly. The currents of the high Arctic are changing. Well, why do we mention that? And Larry talked about this a little bit, because currents are a very important heat transfer process for taking the heat from the equatorial regions and distributing it up to the Arctic. Winds become more important up in the Arctic, but about 50 to 60% of the heat that comes in here is transferred up to northern latitudes. We see this, the climate of Europe is moderated by this current called the Gulf Stream. Those currents could be, and one of the great fears is that if the ice is lost, if the currents are disrupted, then redistribution of heat will be modified. These currents could be modified. And not only will the surface currents be modified, but maybe even the deep water currents. The whole system that we know of the ocean and its currents could be affected. And so you've seen this, again, Larry talked about this. The interaction between the warm pressures, the warm waters and the cooler waters and the atmosphere are going to be changed. And a couple of people have talked about this too, that systems like hurricane events, all these tropical cyclones, may be increasing in intensity and they might be increasing in number. So whether it's storms like Sandy, how ferocious those are, but certainly there's great potential for frequency and intensity. But one of the real changes on the planet that we didn't talk as much about, although there was some suggestion of it, is simply this curve, the increasing population. And why do we think about the increasing population? Well, we have to feed those people. And feeding the people, that about 1/6 of human protein nutrition comes from the ocean. It's the only source of protein on the planet that is still wild. Outside of the blackberries I pick. But those, and so, and this change in the fisheries, is this climate? Well, some of it is. Some of it is just mismanagement. And whenever we have mismanagement, we have situations like the fish, like the tuna and the halibut, and in the American West, the bison, they're gone. You know, they will not recover. Coastal waters are being overfished. Is the open ocean the last frontier? Well, I tell you a story, okay? I lived in Newfoundland for a while. And when I lived in Newfoundland, the Newfoundlanders, they were an independent country up to 1949. And they had a flag, okay? It was part of the British Commonwealth. And their flag actually had this in Latin, and I can't speak Latin. I'm as bad in Latin as I am in German and Italian and all your names. But it really means these gifts I bring, and their gifts are, this is a codfish. And the codfish, this Newfoundland fisherman is sitting by Britannia and saying, I give you these gifts. John Cabot, when he explored the area, he said, you know, there are so many codfish in Newfoundland that England will never be hungry. Well, England was going to be hungry because of the codfish. The decline in codfish has been precipitous. The codfish, these are both the North Atlantic cod stocks and Newfoundland, the Western Atlantic, have gone catastrophic. Overfishing, even codfish on the stamps. You know, how many fish do you know on stamps? And so the codfish were so overfished that they went catastrophic. The fishery is closed in 1990, and it's been closed for the past quarter of a century. The cod stocks may be irrecoverable. England would be hungry. So, and there's a person, old friend of mine, his name is Ram Myers, started looking at some of these fisheries and the declines and the ghost fishing that's going on. And he started looking at sharks. And he said, you know, back in the 50s, you can put out 10,000 hooks and you're going to catch a whole bunch of sharks. And when you catch those sharks, you know, that's going to be, and nobody cared. You know, like, who cares about sharks? And so, but if you went into the 1990s, and you went looking, and there were only like 2 out of all of these that actually caught, the 10 or 20 sharks. All the rest weren't catching sharks at all. And so he published this, and then he started looking at the fisheries captures and going from the 50s, and where you put out 100 hooks, this is you're catching no fish to catching 10 or more fish. This is an ocean in change. And so red is good, blue is really bad. And already by 1950, the fisheries in the Western Pacific were bad. And just kind of watch as they click through, 30 years or so. And this is the status of the ocean today. The ocean is blue. We're not catching the fish. In fact, it was only in about 1990 that the system of the fisheries in the ocean have gone what I would call flatlined. Flatlined in the hospital is not great news. And here, this is the ocean. The ocean is flatlined for the past quarter of a century, 35 years in fact. We're not catching more fish. What is increasing is aquaculture, and that might be the saving grace. That has its own set of problems. So let's go back to that Arctic and look back at this place where you can catch fish. And this is really shallow fishing grounds. And who owns those? And it's really close, you know, it's a lot closer. Instead of going to the Antarctic for fish, you can go from Western Pacific, Eastern Pacific, and go up to those areas. It's a logical place to go fishing. Who owns those fish? Well, nobody. It's international waters. So the United States just recently, in 2009, says we're not going to allow any fish to be taken from those areas until we know. That wasn't the attitude of the Canadian fisheries minister. Has this happened before? Back in the 80s, up to about 1993, there's something called the Central Bering Sea Donut Hole. This is in international waters. It was the greatest fishery on the earth for humans, the pollock fishery, billions of dollars of pollock. It was open water, no limits on catching fish, and guess what happened? Total collapse, total demise of the fishery. It still hasn't recovered today. After that great episode of overfishing, the world in change. 1/6 of the world's protein comes from the ocean. You're not getting it here. Are you going to get it from here before we know how many? So there's an accord that's going to regulate the fisheries. It is this now need for the international agreements. Larry was talking about this, that the programs for around the Arctic are saying, well, maybe we need to start conserving, you know, or managing the fish before we over-harvest them. And the last topic I'm going to mention is going on to pH, because Dr. Orr talked about the pH. You know, we've been dumping all this carbon dioxide in the atmosphere. Highly predictable will be the carbon dioxide will go into the ocean and cause the pH to be lower. The acidity is going to go up. You know, pre-industrial times, now, in the future, and you look at those numbers, you say, well, 0.1, you know, 0.2, 0.1, is it much? Remember, this is a logarithmic scale. This is 30% higher. This is triple the acidity. Organisms like coccolithophores are going to be affected, and you saw the pteropods. This is highly predictable. The carbon dioxide, chemists love this kind of stuff because the Earth works. Most of the time, it doesn't work. And so you have coccolithophores being deteriorating. The food chain, the primary producers are going to be deteriorating. Organisms higher up the food chain, the foraminifera, are not going to be able to have tests. Organisms like crabs and are not going to be able to have chitin, that's hard chitin. There's going to be that collapse. In fact, the ocean acidification, this other CO2 problem, to me is just as concerning or greater concern than the warming. The reefs, as was mentioned, are in trouble. The reefs are getting hammered both directions, acidification and warming, and on top of that, the reefs tend to be located in areas that are greater pollutants. So this is going to be affecting, there are 50 species of corals that are now on the threatened list and could be gone by the year 2050. So the reefs are incredibly threatened. Whole ecosystems are threatened by the multiplicity of acidification, warming, and human impact. So there's a lot of things that on the fisheries, you know, these are all what we could be talking about. And there have been, as far as I know, only one study, Scott Doney of Woods Hole has estimated, you know, these are the impact of acidification on the ocean fisheries. And it's going to, billions and billions of dollars are going to be lost because of a change in the fisheries. So it's not going to be easy to get out of this loop. There's the need for international cooperation, unlike we've ever had before. So, and it's going to be international cooperation among, and why I like talking to educators about this, because you talk to the kids and the kids talk to their parents and say, we got to do something. Okay? Thank you.